Alright, Chapter 5 deals with working with polynomials, and Chapter 5.1, the first thing it discusses is properties of exponents. So what I'm going to do first is just go through and list out all the properties and maybe give you a few examples of each one, and then go through the examples in the textbook. So the first one looks like this. It says if you have a to some power m, and you are going to multiply it to the same base a but to a different power n. It says as long as these two bases are the same, if you multiply you can add the two exponents. Okay, so when you multiply you add your exponents. So an example of this would be something like this. If you had x to the fourth power times x to the second power. A lot of people think that, well, since you're multiplying, you're going to multiply 4 and 2. That's not what happens. Okay, when you multiply, you add your exponents. So x to the 4 plus 2, which we know is x to the sixth power. Okay. The second type is called a power to a power. It says if you have some base number a raised to the nth power, and you're going to raise that whole thing to the nth power, it says that if you have this type of power to a power, all you do is multiply the exponents. So this would be the same thing as a to the m times n. Okay, so an example of this would be if you were to have x to the second power and you wanted to raise that whole thing to the third power. You would say, well, I know that this is a power to a power type example, so I'm multiplying my exponents 2 times 3, and that's going to get me x to the sixth. Alright, the next one, if you had two things inside parentheses, such as a times b, and you're going to raise that whole thing to the nth power. What you have to do in this case is you have to treat a to the nth power and b to the nth power. So really what you're doing is the same thing you did in the example above. Just make believe that there's ones right here, which there are, and you're going to multiply m to both of those exponents. So 1 times m we know is just m, so that's what you're going to have for your a. Same thing for your b. 1 times m is still m, so it's b to the m. So if you want to think of it as kind of like a distributive property, but to the exponents only, that's one way of looking at it. So an example of this would be if you had x to the second power y raised to the fourth power. You would say, well, 2 times 4 for your x is going to be 8. Then you have this 1 here. 1 times 4 is 4. Alright, dealing with negative exponents. When you simplify, they will never want you to leave it in a negative exponent form. So if you have something like a to the negative m power, to get this to become a positive exponent, you just take this and move it to the denominator and make that exponent positive. Because really what you have here that you don't see is you have a to the negative m being all over 1. So when you take this a to the negative m and move it to the bottom of the fraction, all you're doing is taking this exponent and making it positive. Okay, so for example, if we had x to the negative third, that's going to be the same thing as 1 over x to the positive 3 power. Alright, division, very similar to multiplication. If you have a to the m power over a to the n power, when you divide, they say that you subtract your exponents. So this is going to be the same thing as a to the m minus n. So an example of this would be, let's say x to the 8th power over x to the 3rd power. That's really going to be x to the 8 minus 3, which we know is really x to the 5th. Alright, last one that they have in the textbook, and then we'll do some examples. They say if you have a fraction like a over b in parentheses, and you have it being raised to some power m, it's just like the example up here. You're kind of going to distribute that m to both parts. So it's going to be a to the m, because remember we're multiplying, 1 times m is m, and then b to the m on the denominator. So for example, if we had x to the second over y to the third squared, you're going to multiply. 2 times 2 for your x is 4. 2 times 3 for your y is 6. So these are the properties that you need to get extremely comfortable with before you start moving on to the more complicated examples that we're going to get into here in a second. Okay? So if you're having issues with these, maybe stop, go back and look at a few of them. Go in your textbook and look. They've got different examples beside of them on page 330. Go back and look at those examples as well. That might help you out just a little bit. Alright, example 1. Let's go ahead and look at a few of these. There are some that we're going to skip because we don't need to know them. The first one that gives you part A is negative 4 times 2 to the 5th power all squared. So in the book, they do more examples and they do more steps than what you may normally take. But this is going to be, if you look inside here, this 4 and this 2 have different bases. So we cannot just simply add the two exponents. Okay, so if they have different bases, you really can't do anything with them. So you have to move on to the next part, which is this exponent out here. So really this negative 4 has a 1 above it. And remember, if you have two things inside, you're in essence going to distribute this outside exponent. So 2 times 1 for that negative 4, we know is just 2. Times, and then same thing here, 5 times 2 for this exponent is 10, so it's going to be 2 to the 10th power. So all I did was I got rid of the exponent on the very outside, brought it to both terms on the inside, and now I can simplify these both separately, and we know that negative 4 squared, well, anytime you square a negative, it's going to become positive. 4 squared is 16. And 2 to the 10th power, I would use your calculator for that, and just type all this in at once, and you're going to get 16,384. So you will use your calculator for some. You could actually type this into your calculator by itself, but just to get used to the steps, it's good to work them out. Part B on example 1, they give you 11 to the 5th power over 11 to the 8th power. And this is a good example. It's all raised to the negative 1. So a couple different ways you could do this. You could make this exponent positive to start, or you could just simply distribute the negative in. I'm going to do the distributive part first. I'm going to say negative 1 times 5 is 11 to the negative 5th. 8 times negative 1 is 11 to the negative 8th. And we know that what we could do, we could make both of these exponents positive, or we could just simply subtract negative 5 minus negative 8, and you get 11 to the 3rd power, because we know negative 5 minus the negative 8 is 3. And 11 to the 3rd, put that into your calculator, you get 1,331. Alright, we're going to skip example 2. We don't have to worry about the scientific notation anymore for the SOL standards. So let's move on to example 3. This one has 3 parts, an A, B, and a C. Example A says simplify b to the negative 4th, b to the 6th, b to the 7th. Okay, so this one pretty easy. You notice that all of the bases are the same. You have b, a b, and b, so we know that we can work with the exponents using the properties that we just went over. So since we're multiplying all of these, we're just going to add them. Okay, so I'm going to rewrite this as one base, -4 plus 6 plus 7, which we know to be 9. Example B, r to the -2 power over s to the third, all being raised to the -3 power. Alright, so this is a good example. We're going to go ahead and distribute this -3. So -2 times -3 is +6. 3 times -3 for your s is -9. So if you notice here, you cannot simply just subtract 6 minus -9 because r and s are two different bases. So you have to leave them separated, but you do not want to have this negative in your simplified answer. So we want to rewrite this fraction without a negative. So just like we had something that was negative exponent, we brought it to the bottom. If it's on the bottom and negative, you're just simply going to bring it to the top and make the exponent positive. So the r to the 6 is not going to move. That's going to come to the top and become a +9. And when you have it all said and done, all you have on the denominator here is 1. So you don't need to put that into your answer because we know anything divided by 1 is just itself. Alright, last one for example 3, part C. It says take 16 m to the 4th n to the -5 over 2 n to the -5. Alright, this one. I like to work left to right. I like to deal with my regular numbers first. 16 and 2 are just coefficients. They're not exponents, so we just simply divide them like we normally would. If you were to cover up the rest of it here, it would just be 16 divided by 2, which we know is 8. Okay. People get into the habit of dealing with exponents and they start subtracting their regular numbers. They start saying, well, 16 minus 2 is 14, but we know that's not the case. Okay. Then we look at our m. We have m to the 4th on top, but nothing on the bottom to change that m to the 4th. So it is actually just going to stay m to the 4th. And then here's something we haven't seen yet. If you have a base that's the same with two exponents that are the same and you're dividing, in essence what they do is they cancel out because we know that anything divided by itself is 1. But we can also look at it and say, well, -5 minus -10 is 0. So anything to the 0 power is also 1. So we don't need to write that because in essence they just cancel each other out. Alright, got one more example to look at, example 4. This is a multiple choice example, but I'm not going to worry about the multiple choice parts. I'm just going to work the problem out. X to the -3, y to the 3rd squared over x to the 5th, y to the 6th. So you have to know your properties of you have to know your order of operations and your properties of exponents here. So with your order of operations, you know you want to deal with your parentheses first. So inside parentheses, these two have different bases, so we can't combine our exponents. So then we move on to the outside exponent. We say, well, this 2 is out here, and I can just simply multiply it to both of these exponents. So -3 times 2 is -6. 3 times 2 is +6. And down here, nothing's going to change. A lot of people like to, make their negative exponent positive to start, but I usually wait until the very last thing to get rid of my negatives. I'm going to leave it as it is, and I'm going to work with my division. So just looking at the x's, I've got x to the -6 divided by x to the 5th, so I'm going to subtract. -6 minus 5 is -11. Just like the last example where n to the -5ths cancel, these are also going to cancel. Y to the 6 over y to the 6. When you subtract 6 and 6, you get 0. Anything to the 0 power is 1. So now I'm going to deal with my negative exponent. I'm going to make it positive by bringing what is really over 1 right here. You just don't see it. I'm going to bring it to the denominator and make it positive. Okay, so if you need more help with those, try going online and looking up properties of exponents on YouTube. They'll have tons and tons of examples, but hopefully these will help you.